In March 2026, Japanese scientists made history. For the first time, real usable energy was sent down from space. No wires needed. The OHISAMA satellite captured sunlight, turned it into a laser, and beamed it to Earth. Engineers cheered as ground receivers lit up, proving wireless space energy is real. The world took notice. This breakthrough sparked global interest. Suddenly, wireless energy from the stars is real, and people everywhere are asking what comes next. Solar panels have been popping up everywhere, on rooftops, in deserts, and even on floating platforms. But they all share a big problem: nighttime. When the sun goes down, solar panels stop working. Batteries help, but they are expensive and can only store so much power. Many people still rely on gas or coal at night. This problem is worse in places with long winters or heavy clouds. In some regions, the power grid is unstable because energy comes and goes with the weather. Blackouts are common, especially in poor or remote villages. Even the best solar farms lose about half their possible energy because they only work during the day. Space solar power changes everything. Satellites high above Earth are always in sunlight, orbiting above clouds and weather. They can collect energy 24 hours a day, beaming it down anytime, even at midnight. Imagine a world where light never goes out, not because of luck, but because of science. People everywhere could have reliable energy, day and night. It would help hospitals keep running, schools stay open, and families stay warm, no matter the hour. That is the promise of space solar power. You might wonder, why bother putting solar panels in space? Isn't it easier to just build them on the ground? The answer is all about efficiency and access to endless sunlight. On Earth, sunlight gets blocked by clouds, dust, or even just the thick atmosphere. In space, the sun's rays are much stronger, up to 8 times more powerful. On the ground, even the best solar farms only use about 20% of the sunlight that hits them. Clouds, shadows, and nighttime all get in the way. But a satellite above Earth, with no air or clouds, can capture almost all the sunlight all the time. That means more energy, with fewer panels. Some people worry about safety. Could these energy beams hurt birds, planes, or people? The answer is no, at least with today's designs. Energy is sent using microwaves or lasers that are safe at the ground level. The receiving stations are fenced off, and the beams can be quickly turned off if anything enters their path. Space solar power could deliver energy to any part of the world, instantly. Remote islands, disaster zones, or dry deserts, everywhere could get clean, reliable power from the sky. After Japan's breakthrough, other countries jumped into the race. In the United Kingdom, the government launched Project Solaris in 2025. Their goal? Build a solar power satellite that beams energy to Europe by 2030. British scientists are working with engineers from India and Saudi Arabia, sharing ideas and technology. China too has big plans. In 2025, they tested a small microwave beam from a drone, and in 2026, launched their first space solar test satellite. China's goal is even more ambitious, to power entire cities directly from space by the mid-2030s. They are building huge receiver stations outside Beijing and in the Gobi Desert. Many countries see space solar power as a way to fight climate change and become energy independent. Instead of importing oil or gas, they could capture sunlight directly from space. Even developing nations are joining in. The African Union announced plans for a shared satellite, hoping to bring energy to rural villages by 2035. This global race is not just about technology, but about hope. Hope for a cleaner, more equal world. Just 10 years ago, sending anything into space was wildly expensive. Only governments or the richest companies could afford it. But now, rocket launches are getting cheaper every year. Thanks to SpaceX and its powerful Starship rockets, the cost to put a satellite in orbit has dropped by more than 90%. Elon Musk's Starship can carry massive solar panels and hardware into space in one trip. Rockets can even bring back parts to fix or upgrade them, making space-powered satellites last longer. This was impossible just a few years ago. Lower launch costs mean more countries and companies can join the space race. Startups in Europe, India, and even Brazil are designing their own solar-powered satellites. Space is no longer just for astronauts and billionaires. It's quickly becoming a place for engineers, scientists, and dreamers from every country. With every launch, the dream of wireless energy from the stars gets closer to reality. Elon Musk is not just thinking about rockets. He has a much bigger vision. Giant data centers run by artificial intelligence, floating in space and powered by the sun. In 2026, Musk's company announced plans to test the first AI-run server farm in orbit. These data centers would never overheat, since space is cold. And with endless sunlight, they could run all day and night without polluting Earth. Imagine all the world's internet, cloud storage, and AI research happening above our heads. No power plants needed, no rivers or forests harmed. AI could manage the energy beams, moving them safely to wherever power is needed most. Musk says this could unlock new science, from weather forecasting to medical research. If it works, we might see a future where our phones, computers, and even cars are powered by data and energy from space. The possibilities are as limitless as the stars. Of course, space solar power is not perfect. The first big challenge is size. To power a city, you need massive satellites, sometimes larger than a football field. Building and launching such huge structures is still hard and expensive. Engineers are working on lightweight materials and robotic assembly in space to solve this. The second challenge is energy loss. Beaming power from space to Earth isn't 100% efficient. Some energy is lost as heat, and the rest spreads out before reaching the ground. Scientists are inventing better transmitters to make the beams sharper and less wasteful. The third challenge is public fear. People worry about safety. Will the beams hurt birds, planes, or people? Others worry about space debris or satellites falling from the sky. Governments run safety tests and set rules to protect both people and the environment. Education is key to helping everyone feel safe and excited about this new technology. Every breakthrough comes with challenges, but history shows that people can solve hard problems, especially when the prize is clean, endless energy. Imagine a world where no child has to do homework by candlelight, where hospitals run smoothly and water pumps never stop. In this future, energy does not come from burning coal or oil, but from sunlight gathered in space and sent down to Earth. Clean, silent, and endless. Space solar power could bring electricity to the poorest villages, deep in the jungle or high in the mountains. No need for power lines or huge power plants. Just a small receiver and a beam of light from above. Even after hurricanes, earthquakes, or floods, satellites in space can keep sending power to help people rebuild. This technology could also help fight climate change. Less pollution means cleaner air and water. Forests could grow back, and animals would have more places to live. The world would be healthier, fairer, and more peaceful. It will not happen overnight, but every new satellite, every test, and every bright idea brings us closer to this dream. The power grid has been the backbone of our world for over a century, but now it is changing. Wireless energy from the stars could make old wires and towers a thing of the past. Imagine cities where energy flows invisibly from space, lighting up homes, factories, and even cars, no matter where you are. The 2026 test in Japan showed us that the future is not far away. With every launch, every new idea, we are moving closer to a world powered by the sun 24 hours a day. The end of the power grid does not mean darkness, it means a new beginning, a planet united by clean, limitless energy. So, next time you look up at the night sky, remember, The stars are not just for dreaming. They might soon be powering your world. The future really is closer than we think.